This is the 40th video supplement for CIS 351, Grand Valley State University's course on computer organization and assembly language. This is the second of 3 videos that discusses how to call functions in assembly. This video demonstrates what happens if data in a register is unexpectedly overwritten by a function that's called. The next video discusses the conventional way to avoid such problems. The previous video examined the assembly version of this code, which determines which of 2 prices is closer to some target price. The assembly code worked fine when there was only one level of function calls, when absolute value was the only function called. However, when we added a second level of function calls, where we called closest price as a function, which then called absolute value, the code entered an infinite loop. Let me show you. So we'll start at the beginning and enter the closest price function, then call absolute value one time, return, call absolute value a second time, and return. When we go to return from the closest price function, instead of coming back up to main, we end up coming here to line 32 and loop infinitely through the last few lines of closest price. So if you haven't done so already, pause the video and see if you can find the source of the infinite loop. Let's step through this code again slowly and watch carefully. So we set up our parameter values, and now we're going to call closest price. When we execute that jump and link instruction, notice that the return address register gets the value 00400010, which is the address after that jump and link instruction, which is what we want to happen. So now we move through closest price, and now we're going to call the absolute value function. When we execute this jump and link, that jump and link replaces the value in the return address register with its own return address, which is the address of the instruction after the jump and link for absolute value. That's going to cause a problem later. But for now, things work just fine. We finish the absolute value function. We return back to closest price, calculate the absolute value for the second price. Notice that when we executed the jump and link instruction, the return address is now the address after the second call to jump and link. And we go through and finish absolute value. And now we're back in closest price, but register 31 still has the return address of that second call to absolute value, not the return address for closest price. So even though the intention of the code is to return from closest price, the value in the return address register causes us to jump back up to the line right after the call to absolute value. So then the CPU just walks through the last few lines of closest price again until it hits that jump register and the loop starts over. So we're stuck in this infinite loop because the return address value is not what we need. So how do we fix this? We need to somehow protect that return address value by moving it out of the way so it doesn't get overwritten. So let me quickly show you a simple but incorrect solution. So we could simply take that return address value and save it in a different register. Let's say T8. So now T8 holds the return address for closest price, so it's not lost when the 2 jump and links run. So when closest price is done, we can use T8 as our return address instead of RA. So now if I run the program, when it comes time to return from closest price, we do have the correct return address and we end up back in the main function. This fixes the immediate problem, but it's not a good general solution. To see why, let me show you one more problem with the code, and then we'll fix both problems the correct way. Notice that when I wrote absolute value, I used register T9. There's nothing wrong with that. We have all these registers, and it doesn't really matter which ones you use. But starting with T9 is a bit unusual. I imagine most programmers would begin with T0 just out of habit. Why not start at the beginning, right? So let's see what happens if I happen to do things the more typical way and use T0 as my register in absolute value instead of T9. So now I'll run the code. And when I'm done, if I look in V0, I see that the answer is 1. Well, that's not the right answer. The answer should be the price that's closest. And since the two prices given were 9 and 12, my answer should either be 9 or 12. So there's another bug in the program. Pause the video and see if you can figure out what went wrong. So once again, let's step through the code slowly. The first thing we do is set up the three parameters to closest price. Price A, price B, and target in registers A0, A1, and A2. And we'll call closest price. Because I need the A registers to pass parameters to absolute value, I'm going to move them out of the way into T0, T1, and T2. So now T0 is my price A, T1 is my price B, T2 is my target price. And I set up my subtraction. I put the answer in A0 so I can take the absolute value of that. I execute absolute value. And this line right here is going to be a problem. Notice what's in T0 right now. 9. That's my price A. But now, when I do that set less than to check and see whether the parameter to absolute value is positive or negative, I just overwrote that value of T0. So I go and finish the function. And when I come back to the closest price function, T0 still has the value left in it by the absolute value function. Because remember, T0 is a hardware resource. It's not an abstract concept. So when any function changes a register, that register's value is permanently physically changed. It's not just a data structure somewhere like it is with C code or Java code. So this will be the source of our problem, as we'll see in just a minute. So we continue on. We make our second absolute value call. This time that set less than is true, leaving the value of 1 in T0. Finish the absolute value, come back to the closest price method, compare the two differences, and now we're trying to take that price A, which is the closest price, and move it into V0. However, we're going to get the wrong value in V0 because T0 doesn't have the value in it that we thought we had left in there. The intention of the programmer who wrote closest price was that T0 always contained price A. But our call to absolute value changed that, so we're putting the wrong value in V0. So when we return from closest price, it returns the wrong value. So we've now seen not one but two values clobbered by function calls, which should make you wonder, is there a general way to avoid conflicts over register usage when calling functions? Well, of course there is, and I'll show you how in the next video.